All right, let's look at formulas. So in this section of the exam, there's quite a few different exponent type things. So we'll look at that, a couple of probability type questions, and one distance question where distance equals rate times time. So some of these sections can overlap a little bit. I've said this in a lot of videos, I guess. If you see something in more than one video, or it shows up in more than one section in the app, there's a good chance it's going to be on the test, right? Okay, so first one, multiplying exponents, right? And the second question down there will be dividing exponents. So we'll do these two first before we jump into negative exponents. Okay, so we have 3a squared b to the fifth times 4a to the third b. Okay, and so first of all, when you see just the b right there, that means we need a 1, right? Because that's b to the first, right? So that we can add them. So start off 3 times 4 is 12. No problem there. Okay, and then we're going to add up the a exponents first. 2 and 3, so we got a to the fifth. And then we have b to the fifth and b to the first, right? B to the fifth, b first, 5 plus 1 is 6. There you go. So a lot of times when you watch somebody else do it, it seems awfully easy, but important to remember that it's adding. When we're multiplying exponents, that you add those exponents, don't multiply them. If you multiply them, we will not get the right answer. Okay, jumping into dividing exponents. And we have x to the sixth divided by x to the fourth. So when we divide exponents, subtract. So 6x to the sixth minus 4, that's going to be x squared. Okay, pretty simple, right? Important to know though, because it'll show up. So when we're multiplying exponents, add them. Dividing exponents, subtract. Okay, so there's our first two. If you got those, you're in good shape for quite a bit of exponents. It won't cover everything. We'll get to the other stuff here in a sec here. But those are some big parts of exponents to get right. There will be exponent questions in this section for sure. Okay, next. Negative exponents. Okay, people get tricked up on these a lot. So we'll write out 3 little examples here. 2 to the negative 2, 2 to the negative 3, 2 to the negative 4. Okay, so for negative exponents, we want to turn these into a fraction where the numerator, which is the top part of the fraction, is 1, and the denominator is the base with a positive exponent. What in the world did I just say? Okay, so we said 1 at the top, right? And then divided by the base, which is 2, to a positive exponent, right? And that exponent is 2, and so we're just going to say make that exponent positive. 2 squared is 4. That is the correct answer for 2 to the negative 2. Okay, we'll do another one. Sometimes you got to see a couple of those, right? Again, there's the simple part. 1 is at the top. At least know that, right? Is if there's an answer where 1 is not at the top, at least eliminate that as one of your possible answers. Okay, but there's really no reason not to be able to get this, right? There's just one rule to know. Okay, here's my base, 2. Here's my exponent, 3. So it's just 1 over 2 to the third, which equals 2 times 2 times 2, 1 to the eighth. Once more. Okay, 2 to the negative 2 equals 1 divided by 2 to the positive 4. 2 to the fourth is 16. It's just 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Okay, that's how you do negative exponents. Okay, it's not impossible. Sometimes people get freaked out. They just don't know what to do with it. No reason to freak out. You can handle it. Right? If you need more practice, get into that app, get into the Whipsmart app. And there's tons of practice questions. Right, this section is on formulas, and you'll see all kinds of exponent questions. Okay, what else do we got? Okay, what if you saw something like this? 4 squared plus 4 to the first plus 4 to the 0. What's that equal? Okay, so most people are pretty good on 4 squared, right? That's 16, right? 4 to the first, that's just going to be 4, right? So any number to the first is just the base, right? And the base is this number right here. Okay, so that's 4. And any exponent to the 0 just equals 1. So whether it's 400 to the 0 or 4 to the 0, they both equal 1. And then if we add all these up, we get that, 21. Okay, and one other exponent type thing, and then we can move on to probability. Again, right there, anything to the first power just equals the base. And anything to the 0 power equals 1, doesn't matter what the base is. Okay, so what about this one here? A to the n with the m being the exponent. Okay, if you see something like that, that equals a to the n times the m. Okay, so people sometimes get that confused with like what we did first when we were multiplying exponents. So like you get it confused with like a to the n, that's a times a to the m. These are two different things, right? These two things are not the same. So just remembering when you have you got two exponents here, right? One inside the parentheses, one outside of the parentheses. You multiply these two exponents together. Hopefully that's not too confusing. If it is, same thing. That just means you just need practice at recognizing it. That's the trick, probably the trickiest one of the exponents, in my opinion. I see people miss the most. You can handle it, right? Just getting used to when you have those two exponents, multiply them together. Like when they have to be right next to each other, though, right? When multiplying exponents, we add them. Those are different things. Okay, probability. So with probability, so real typical questions are like flipping coins, rolling dice, and cards questions. So we'll start off with a coin question. Okay, and these all really have to do with like consecutive events a lot of time. Okay, so we flip a coin 3 times. What are the odds that it's never heads, let's say, or tails? It would be the same odds. Let's say never heads. Okay, so when we flip a coin, 1/2 chance, right, that it's heads or tails, 50-50. Okay, and when they're asking us for consecutive, we always multiply the odds together. That's probably the most important concept here for probability is when asked for consecutive events, multiply the odds together. They said 3 straight times, what is the odds that it's never heads, right? There you go. Just multiply those 2's together 3 times and get 1/8. If it was 4 times in a row, it would be 1/16, right? We just multiply it times 2 one more time. Okay, and that's your coin type questions that you get. Consecutive events, coin questions. What it would be the odds of just 2 times in a row? 2 times in a row that I don't get heads. 1 out of 4, right? 1/2 times 1/2. Okay, then with dice. So with dice, right, there's 6 different numbers on a die. And so 3 times in a row you roll a 6. Same exact concept. Just that rather than times 1/2, these are going to be times 1/6. Okay, and if you just understand this, there's at least one question, if not two. They're going to show up with this concept. So 6 times 6 is 36. And 36 times 6, if you multiply that out, is 216. Okay, so 3 straight 6s, not terribly likely, right? Less than 1%, less than 0.5%, 1 in 216 times. We roll 3 straight 6s. Okay. Get rid of this guy, and then we got one card question here. All right, what's the card question? Okay, a deck of cards has 52 cards. There are 4 aces in the deck. After drawing a card, it is discarded, meaning that the card cannot be drawn again. What is the probability of drawing 2 straight aces? Okay. 2 straight aces. All right, so we start off with a full deck, right? There's 4 aces, 52 cards, right? Okay, and so we can reduce this if we divide each side by 4 to 1/13. Okay, so if the question was just there's 4 aces in the deck of 52, what's the chance of drawing an ace? 1/13 would have been the answer. Okay, but they're asking again consecutive, right? 2 straight aces is what they asked. Okay, and again, whenever you hear consecutive, that means multiply. It means you're going to multiply the odds together. Okay, so we started off, we've got 1/13 chance of getting that first ace. And then they said the card's going to be discarded, right? So now there's only 51 cards left in the deck. And how many aces are left? 3, right? Because we already got one. Okay, and then you just multiply these together and we get 3 out of 663. And your answers will probably be in some kind of a percent, so you can reduce this actually to 1 in 221, or about 0.4%. Okay, and there's your answer, right? And most likely, they'll make it fairly obvious where it'll be like they'll approximate it like less than 1%, 3%, 5%, 10%, something like that. But there's your way of solving that one. So again, all consecutive events, we're multiplying the probabilities together. And flipping a coin, rolling dice, picking cards out of a deck, those are very common ways to ask about that and good ways to practice. Okay, and then finally we have distance equals rate times time. Okay, so I know that distance equals rate times time has shown up at least one other video, maybe more, for this exam, and all that means is get ready, it's coming, right? So you need to be ready for distance equals rate times time. Here's a different type of question. We haven't seen this exact question. So it says Andy drove 200 miles in 4 hours yesterday and 180 miles in 3 hours today. What was his average speed? Okay, so we went 200 in 4 hours yesterday and 180 in 3 hours today. and they want to know his average speed, which that will be the rate, yeah? Okay, so here's the mistake people make. They go like, all right, 280 divided by 4 is 50. That's 50 miles an hour. 180 divided by 3, that's 60 miles an hour. Combine the two, average them out, 55 miles an hour. Okay, don't do that. That's wrong. Okay, why is it wrong, right? It's going to be an answer choice, I can tell you that. It's wrong because the time periods are different, right? So you can't just average these out because it was more hours driving at 50 miles an hour than it was driving at 60 miles an hour. So you stick with the formula. Like that's my suggestion, stick with the formula. Okay, so the total distance is 200 plus 180. Yeah, so that's 380. Time is 4 plus 3. That's 7. And rate we don't know, right? This is a better way to do it. Okay. And if you go 380 divided by 7, that ends up at 54 miles an hour. And there's your answer. Okay, so that's everything you got to know for formulas. So we went over exponents. You do need to be familiar with how to multiply exponents, add them. How do you divide exponents, subtract them. How do you do negative exponents? We went over that. The probability stuff, especially for coins, dice, cards, and then finally here we ended with distance equals rate times time.